In one of the fastest growing cities in the world, a love affair is blooming. Melbourne's residents are talking to their trees. A conversation is unfurling.
Dear 1517, I am confessing something very dear to me. I have fallen in love with 1583. Should I leave? Or should I stay? It would be great if you could give me some advice.
Around the world, more people are living in cities than ever before.
How's it going, 1517? I've been wondering, what's the city like for you?
If we change our perspective, we can see that trees are nature's great connectors. When trees breathe, so do we. Each breath cleaning the air and restoring balance. Our past, present and future are intertwined with trees, yet we have lost the ability to see them. To thrive, we must fall in love again with our city's trees and nurture our urban forests.
Hello, 1517. We don't have a lot in common, you being a trindle. I'm glad we're in this together. Regards, a tree lover.
Hello, tree. It's your mother. How come you never call?
Hi folks! At this year's State of Unreal at GDC, we offered a first look at an experimental new procedural content generation feature and more in a demo entitled Electric Dreams. Now you can get the complete environment from the demo as a free sample project. Head to unrealengine.com/feed to learn more and download the sample from the Unreal Marketplace today. Another month, another sale. So while you're grabbing that new sample, take a look at June's Marketplace sale with over 1,500 products now 50% off, including environments, props, VFX, systems, and more. The sale ends June 25th. We're at the halfway point for our animation challenge. You still have time to either use Unreal Engine or Unreal Editor for Fortnite to show us your best moves and animate your way to be in for a chance to win $1,000, swag, and more. Learn more on the feed. In ecosystem news, we're pleased to announce that Reality Scan is now available for Android and iOS devices, putting this powerful, free-to-download photogrammetry application into the hands of almost anyone with a modern smartphone or tablet. Rocketing over to this week's Community Spotlights. Discover untold wonders, conquer natural hazards, establish epic bases, and battle enemies as you build your way to victory in the upcoming open-world PvE survival game set on distant alien planets. Wishlist Terratech Worlds by Payload Studios on Steam. Environment artist Nash Jalovkin's latest work is a testament to their skill and passion for environments and assets. Stylized Town Alley features detailed stylized PBR shading and provides them with an interesting opportunity to learn lighting in UE5, along with other tools to make their environment stand out. Learn more about how they did it on their ArtStation. Inspired by Mikey's Japanese garden concept, 3D environment and prop artist Primal created their first fully realized environment in Unreal Engine 5 after a break from 3D. They took full advantage of megascans and their own modeled and textured assets to create this tremendous piece. We think you'll all agree that Primal hasn't lost their touch. Let them know what you think over on the forums. Thanks for watching this week's news and Community Spotlight.
Hello, everyone, and welcome back to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Tina, and today with me I have some of our incredible developers who are behind the newly released Electric Dreams sample project, which is incredible. And if you haven't already, I highly recommend taking a moment to go download it. And who knows, maybe you can even follow along with some of what we're going to be doing today. So go check it out if you haven't already. But with that, let's go ahead and get into introducing our guests for today. So first, we'll start off with you, Jean-Sebastian, which I will refer to you as JS after this, but just so we can get the full intro, would you mind telling us a little bit about yourself?
Sure. So I'm Jean-Sebastien, JS for everybody. I'm a technical art director working with the Unreal Engine development team, mostly on world building and procedural developments. I've been working in the game industry for the last 20 years now on a lot of AAA titles, and I'm enjoying myself right now working on the procedural development. So I'm happy to be here today.
Awesome. Good to hear that you're enjoying yourself. That's always important. Then next, Julian, would you like to tell us a little bit about yourself as well?
Sure. So Julien here. I'm the lead in the Unreal Engine Procedural team. So I started PCG. I've been at Epic for a bit more than 2 years, but is it 3 years? It's going really quickly. I've been in the industry for yeah, exactly. Yeah, I've been in the industry for about 15 years. You might know me from Destruction and Rental 6 Siege also. And yeah. That's it.
Awesome. That's it. No big deal. Just 15 years in the industry, whatever, you know.
Yeah.
And then last but certainly not least, we have Adrian. Would you mind telling us a little bit about yourself as well?
Yeah, hello everyone, I'm Adrian. I'm working at Epic since 1 year right now. Got pulled in by Julian. Did some machine learning before with Julian, and yeah, he pulled me up to work on PCG last year. So, and very happy to work on this incredible plugin. Really having a lot of fun.
Awesome.
And you're selling yourself short. So, yeah, I was gonna say he also does like tutorials on YouTube for PCG and everything. So he's
you might know me for my tutorials. Also, I try to answer questions on Discord. So it's me.
There we go. See, can't leave out important check marks like that. Thank you so much for pointing that out, Julian. But yeah, I'm very excited to dig into today's topic. The Electric Dreams project is massive, and there is just so much available in there. So I am so ready to get in and dig around and see what all we can learn. But before we do that, if you don't mind, for anybody who's watching who might not be familiar with the project and what it is, do you mind kind of giving us a short explanation of what exactly this project sample is for them.
Yes. Okay. So the Electric Dreams demo was at GDC this year, and we've shown the new experimental tools for world building, so the procedural content generation framework, as well as Substrate. There's Soundscape in there. There's obviously Nanite and Lumen to dig into and look at how to build such a big environment with all these techs. Really for the sample here, it's an environment. It's the exact same environment as we've demoed at GDC, where you can use it as a educational material, basically, to look at everything, how it was done, and build your own tools or build your own environment following these examples. So really the sample there is for you to look into, dive and find out the great new stuff that we've shown.
Awesome.
I think I can probably cut to my screen already because we have so much stuff to tell.
Yeah,
let's
it's going
do
to be a
it.
packed one.
Cool. Okay, so I'm gonna present or introduce the sample very quickly, and then we're gonna go into PCG a lot more in a lot more technical details. But let's start with the Electric Dreams sample as it is when you get inside after downloading it. So the first thing you'll see is you'll be presented in a startup level with a bunch of requirements for minimum or recommended specs, and a list of levels where you can find interesting things in. What's important to note there is that obviously the two first levels, so the Electric Dreams environment and Electric Dreams underscore PCG maps, are resource intensive, and they're best experienced with quite a good PC there. But it's also divided in a way where you can open up smaller levels like the PCG close range and the breakdown levels if you have a smaller PC and still experience everything that, well, yeah, part of the things that we've shown separately, so you don't have to have the recommended specs to open those levels. So as I said, the most important level there is the Electric Dream underscore env, and I'm gonna open that one. It is exactly the same level, the same environment that we presented at GDC, and it contains both the encrafted section and the procedural section mixed together over a 4x4 kilometer world. It's also playable, so you can go in Pi. There's a drone in there, so you can navigate around the environment. No vehicle. Sorry about that. I know that's gonna come up in the questions. Yeah, it's unfortunate, but yeah, we wanted to get the demo out so people can look at the tech. Also, during Pi, you can play back the sequences. And even manipulate everything that we've shown again. So here, I'm just gonna reduce the mouse speed a little bit so I don't make everybody sick by moving. You'll see some text information when you load, and there's a few text boxes playing around in the level to tell you what to look for. And I think I'll buy just right away, so it's easier to present. Grab my controller. Shouldn't be too long. Okay, we're in. Great. Okay, so when you start from the very beginning, the first thing that you'll see is the substrate material ball. So you can pick that in the editor and look for the material and look at how it was built. You have the fluid simulation model there. You'll have to find a way to activate it, but I think it's worth looking into that. And then this is all the incredible handcrafted section that was built by the Quixel team with the Quixel Megascan assets. It's great looking and very well made. So there you go.
Alright, yeah.
It's insane. Or should I say it's unreal? Right. Okay. Let's get into the procedural section that we're gonna talk a little bit more about today. So from this point on, we're in the procedural section, and as I said again, you have access to everything that we've demoed from that section. So if you want to drop the large assembly, you can press F8. That's the drone camera here. Okay. Go under the content browser, and under content, PCG, asset, you'll find Blueprint PCG large assembly. And that's a large structure. You just drag and drop it in the scene there. And you get the instant update of the environment. You can move it around if you want. So let's bring up the gizmo. And again, as we've demoed, everything updates live and on both sides.
Yeah.
Right. Okay, the other thing that you can do there, and while you're in Pi, I'm just gonna go back to the drone camera. You can launch into the sky. So Shift V is the shortcut, and that starts the playback of the sequence camera. Which brings you up to what we call the mid-range level, or the mid-range sequence. And from that mid-range, you have access to Forest BP, so PCG demo Forest blueprint there. And on that blueprint, you have all the parameters that were interacted with during the GDC demo. So you can change the density of trees, right? So let's reduce the number of trees, and that updates live in your Pi session. You could scale trees down a lot, making them very small. Or you could bring the large cliff structures all around and change the seed to change the distribution of those large cliffs. So that's all available. You can just play around with it. But the interesting part, which is coming next, is how we've built that thing. The next shortcut would be Shift B, which toggles the what we call the long range or Vista camera. And something that we haven't shown during the GDC demo was that we could cycle the backgrounds live, because we stored the procedural settings into separate structure, and then we're just applying those settings live as we are cycling those settings. That's pretty cool.
And because
Another thing that
this is a
sorry,
I was gonna say this is a kind of a lightweight graph, and so it's super snappy when you change it. So it makes for a big visual difference as well.
Exactly,
And
and
it's
I think from
generating at runtime also. It's not pre-computed. You're
Oh
cycling
yeah,
and
yeah.
it's computing at runtime.
Yeah, exactly. That's all generating runtime. The interesting part there is also that you can start to understand how we divided the scene. So we started from a close range area, which was the riverbed, and then we went on in the mid range, which is the base forest at the bottom of the mountains, and then there's the vista background rules. And all of these are separate rules, separate procedural rules. They were even built by different people. We were 3 technical artists working on this, so we separated some of the rules, and yeah, you get the idea. So cycling the background there is an interesting thing, but it only impacts the large, long range Vista stuff. I can even cycle procedural forest there, and
Right.
show different presets. Something that we haven't shown, and why we haven't shown these is because we think that it's better for everybody to have control on the inputs and really understand what's going on and be like take action on the procedural instead of like I feel lucky button, which we don't think it's the right approach to procedural. Okay, so that's the environment. It's the main environment. I'm just gonna exit pi from there.
Yeah, you could have shown like just to clarify. You know, we're not cheating. You can go in the forest really far away, and it's still the same level of quality. It's still the same thing.
Right. You're right. So if I move here and look down at like the clearing on the forest, like you can see how many assets there's in there, and it extends up to like the very end, and even the forest in the mountains, like the trees are like all nanite trees. These are nanite mountains. It's quite dense and quite impressive, I think. I can try to go in the nanite visualization there. Let's try clusters, but yeah, that's a lot.
Yeah, and the one thing that was also interesting in the demo is that in the large scheme of things, we worked on this demo for a reasonably short amount of time, and it still created a very large environment that looks really good.
Okay, so for the other levels, as I said, we have Electric Dreams PCG underscore PCG, which is exactly the same level again, but without the encrafted section in the middle. So we only have procedural world building in that case. The other levels, we have PCG closed range, which is just the riverbed, so a lot less resource intensive, and you can look at it in the context, in the limited context. And then we have breakdown levels, so like for each of the most interesting rules that you can look for. So the large assembly by itself, the ditch embankment, spline there by itself with the assemblies that were used to build it, a forest on a flat ground patch, and a spline example that I'll show later a little bit more. So I
Right.
think before we get into super technical procedural content generation framework, we should introduce it. So I'll let you.
Yeah, so like, please go start and make something from scratch. Yeah, so and Adrian, feel free to interrupt me. So the procedural content generation framework, which we are gonna call PCG because it's much faster to say, is a plugin that's in an experimental state at the moment, where we're giving you tools to build procedural content in your games, whether that's fully in the editor or partially in the editor and partially at runtime or at runtime. We're trying to allow these things to happen and still keep something very iterative in the editor so that you can do something cool with it. It doesn't need to be super complex. You can come up with a reasonable or passable forest in like a very low number of nodes, which you might have seen already in some tutorials and everything. But basically, it boils down to a couple of things that you deal with in PCG. First, you have a graph, which is basically instructions on what to do with the data. And then you have a component, which is a PCG component, holds the graph or the graph instance to be exact, and that's where you're gonna do final tweaks, and that kind of like makes it a real thing in Unreal. Right. So from there, in the graph, well, first off, it's not a blueprint graph. It is, it's not a sequential graph like an execution graph, or it is a data flow graph. So things can be executed even if there's no inputs or there's no pin driving execution, and that we're going to derive the execution order based on dependencies, and that also allows us to do parallelization of computation if we need to, without you having to worry too much about it. Yeah. Now talking about data, well, data is kind of a hierarchy in PCG. You have spatial data, which represents anything physical, like a volume. It could be a mesh. It could be a surface, like the landscape, or it could be points, or it could be a spline. And you also have attribute sets, which represent parameters you can apply and multiple of things, which we'll dive into at some point. And as far as the hierarchy go, let's say the landscape is a surface. The surface is a spatial data. So the I would say like the thing that builds the hierarchy is that there's some operations you can do over any kind of spatial data. So anything that is a spatial data, you can get points out by calling 2-point, or basically sampling it. You can also build a relationship between data, like intersections, unions, differences, and eventually also project data, some data set over some other data set. And these work at the spatial data level. So the data types in the graph are evidenced by colors. So sometimes it might get a bit complicated because the landscape is a specific color, but the surfaces are a different color, and spatial data is a different color as well. We try to find something that's legible, but it's always going to be a work in progress. Yeah, so that's it for the data. The first step. Anything I missed, Adrian?
No, I think that's good. Just want
Okay.
to chime in on what Jess is doing. So this is very simple graph where you're just taking the landscape and try to sample it by plugging the landscape into a surface sampler. You get some points as output. If you press the D key or right click and select debug, you can see these boxes that helps you debug the bounds of the points that you have. And they have also different colors because the debug has the density encoded into the color. So density is a property for a point, and like black means low density and white means high density between 0 and 1. Then to get points as output, so you can transform it, apply random rotation, random scaling, and you can also inspect the node when you get the list of all the points. You can double click on it. It will jump to the points that you are looking for, which is very useful if you see like some weird values, and you can see what's going on quickly. So yeah, transform points, and then you can plug it into a static mesh partner, which will spawn some trees in this case because just choose to spawn trees. And yeah, that's a very easy way to, with 3 nodes, to get something that you could have the whole landscape populated very quickly with a lot of meshes with just 3 nodes.
Right, and I was talking about operations on data. Well, when you do a difference, whether it's point to point or surface to point or something else, or volumes. In this case, that's what JS is showing, right? He's getting the actor data based on a given tag. Not sure what you picked, JS, but basically he's sorry, rock. Okay, right.
Rock, yeah, that's awesome rocks.
Yes, these are somewhat spherical rocks. So basically, he's from the points he's generated or sampled from the landscape, he's removing all of them that actually touch any of these rocks. So it allows you to build something that's a bit more logical and remove some interpenetrations. It would also be possible to do that upstream on the bounding shape, but we're not gonna show that today. But it is possible to keep sample on something that is more complex, or with more restrictions than just the surface, for example. And by default here, when you don't plug in the bounding shape, it's going to use the the volume you're running on, or let's say, the bounds of the thing you're running on. Because you could actually have a PCG component on something that is not a volume, and that's what we do, for example, when we do blueprints. I think in the demo, GS, if correct me if I'm wrong, but the actors have a collision, or they have a shape, I think, or a collision shape or something in no volume and just a PCG component, and that's sufficient. PCG is gonna be able to pick up the actor data by itself when you need it.
Yes, well, I think we'll see that later. But yeah, the PCG component can be used on blueprints with a box collision, a spline component, or anything that would work with the PCG basically.
Yeah.
So that's how we've built the demo. We constructed those actors outside of the world as content, and then we can drag and drop them in any world as tools basically.
Yeah, as far as what a PCG is able to ingest at the moment, when you do get actor data, we're gonna look for a couple of things. There's a special case for the landscape or partition actors, which we might talk about later. But then we're gonna look if there's some shapes. Is there any primitive data so we can get the collision, or is there a spline? Things like these. And if we find more data types we're interested in the future, we'll make them be parsed automatically as well. Right. So let's go on. I think we should talk about user parameters quickly. Um, Basically, it ties in a bigger topic, but PCG, you have settings per node. Like a node is basically its settings. So which drive the behaviors, which you can set in like a static version, right? But you can actually drive some of these parameters at runtime. So you can do some computation and come up with the value you want in a specific field, for example. Or it could be something you've exposed to the graph instance, which I think JS is doing now. So that allows you to, it's the better version of what we had on Blueprints before, which actually what we have in Electric Dreams. It's the more general approach. So basically, you're able to expose a variable that's going to be visible in the graph instance, so you can change it per instance, and that actually translates as well when you use subgraphs, because a good way to refactor logic and reuse some parts of your graph is to create subgraphs. But then sometimes you do need a bit of control, so you can expose parameters as well. So if you don't provide new values, you still have default values. But if you've provided values, you could drive and control a lot of things, which is super useful. It allows you, a lot more flexibility, and it does give you flexibility in general with the attributes to be able to build a relationship with the data, right? So you can have something that generates, let's say, small or big rocks, and then have the same subgraph doing something slightly different if it's a large rock or a small rock, and so on. So you have something that's a lot more reusable.
Just a quick note on the
yeah.
parameters. Not all types are supported in parameters.
True.
So we only supported like the basic types, like floats, double, vectors. We don't support arrays. We don't support structures yet. We don't support in 5.2. We don't support the soft object reference to any object, but we are supporting soft object path. So you can use them to pass meshes, for example.
Yep.
But you cannot set a static mesh soft object reference because it won't work. It's something that we are iterating on, and there will be more functionalities and I think better explained in 5.3. But right now it was still a beta.
I mean, that feature came in pretty hot, close to the release, to be honest.
Yeah.
So yeah,
there are some few problems with vectors that updates on override, it won't update correctly. So
You'll see as well, like it came out and for 5.2, and it wasn't even a part of the demo because we didn't have it at that time. So everything that we've done in the demo was using blueprint variables that we're getting inside the graph instead. So it's still a valid way of doing it. But obviously, the more we are going to progress into the development of PCG framework, the more we'll want the parameters to be exposed and properly be used. But going through blueprints and variables and getting those variables within the graph is also fully working. It's valid, and it's that's the way we built the demo basically, because we didn't have the access to the parameters yet.
Yeah, and finally, I think there's a couple of things we could mention here quickly. Where you're using a static mesh spawner here, and people are sometimes asking, why we pick this type of ISM, or what we're doing here is basically we're gonna bundle up the most efficiently the meshes together in an instance. So it's either going to be an HISM or an ISM, so instant static mesh. So currently we pick up the version that matches what we know about static meshes, but at some point we might change that, because sometimes it would be nice to be able to pick yourself, but still not done. Similarly, when you spawn actors, because there's a spawn actor node, if and you can actually merge the result of the actors. You don't need to do it now, but basically we can collapse the actors, so we take the data that we're able to process easily, like the meshes and stuff like this, and make that a more efficient version. Instead of spawning, let's say, 1 million actor, we're just gonna take out the meshes and create an ISM out of it. And if it were using PCG as well, instead, we could just forward it as a 1 million point kind of thing, instead of having, again, 1 million graph executing. Still a bit advanced, but sometimes there will be use cases for that. All right.
Cool. I think that's enough of the PCG
Intro.
basic
Yeah, for sure.
introduction. So how did we get from this thing here up to the Electric Dream visuals? And that's, I think, the interesting, very interesting part. So
Just a few more notes. That's all.
Yeah, a bit more notes,
just
and
a few more notes.
some elbow
Okay.
grease as well. Yeah.
Right. Okay. Let's jump into this. I'm gonna go into the close range world. So PCG close range.
Did you want to answer questions first, though? Say, is there any burning questions, Tina?
There's a couple that I think could be helpful to answer before we dive too much further in.
Okay.
The first of those is there's a question about if landscape is required for PCG to function.
It is not. It's definitely the easiest way to interact. When you want to sample in the landscape and everything, but you can also sample against the physical world using the world ray it query. Basically, what it does is that because it came up on Discord, and I know Adrian had answered that before, but the idea is that the world rate query kind of creates you a virtual surface of an unbounded size, and then when you sample against it, that's where we're actually going to do some raycasts, and then from against the physics, and then that gives you points, and you can do stuff with it. So that comes at a higher cost than checking against the landscape, which is super efficient to get data like this, but it's still a very reasonable way to do it.
And it's quite a good question and a good timing, because that world has no landscape, and everything you're seeing there was built from the procedural tool. So it doesn't require a landscape. Obviously it's a very good input to start with, but you can build stuff out of splines like this, or other meshes, or sampling other things.
Awesome. I think everything else I'll save in my back pocket for after the next section here. I think that was the main one that people were really wanting to know.
Cool. Okay, so the close range section. Why I'm starting with this? It's because every rule that is in there is dependent on each other. There's three main roles. There's the large assembly that I've shown earlier. So when you move it around, it updates. So you get the idea there. Like the ground is dependent on the large assembly, but it's also dependent on the ditch embankment side spline there, and they all exist because they're all there together in the world. So let me change, for example, that spline shape a little bit. Oop, okay, and you'll see that, and that's something we haven't shown, but you'll see that the ground updates, the ditch updates, and the fallen tree along the embankment wall would only exist where the ditch embankment is. Okay, so let's dive in the first rule. The first thing is that I'm going to talk about is the ground, because the ground is really constructing itself based on the other two things. Let me just reset this thing because I've changed it. So close range. Okay, and I'll start by actually removing everything that was generated. So I'll clean up the large assembly, but I'll keep the actor in the world. And I'll pick the ditch and I'll clean it up as well. There you go. So we're left with the ground surface. And you can see that in the ground surface, there's only ISMs. If I clean up the ground result, there's no other component than a box required for the PCG component to exist and work, and the result of the procedural generation. Okay, so I'll dive into the graph here. Don't be scared. It looks complex. There's worst in the demo, but it's not that hard to follow. So the first thing, and I think that's a good advice for everybody, look for the spawner node, so the green like static mesh spawners and spawn actor nodes that you can disable. That's the first thing you want to do to really get into how we've built those. So give me a second.
Yeah, there's a couple of those in here. Yeah, I think that's all of it.
Yeah, I think that's it. So I pressed E. E on the keyboard will just disable or enable the nodes. And everything is still being processed, but there's nothing being spawned. So I don't have any ISMs being created here, as you can see. But the whole logic is still being processed as I go through and change the values and debug the nodes one by one. So that's a very useful way of doing things, and looking at the graph is disable everything that was spawned and go in and debug the nodes one by one or like per section. I left myself some breadcrumbs trail here, so it's easy for me to go through the graph and explain during the live stream. But the first thing here is we're using the getters for the splines. So if I go back to the ditch, we have the surrounding area spline. And if I pick the large assembly, there's the large assembly spline. So we get both of these spline data using all of world actors by tag and with specific tags for each. And then we sample them. So we create points for the area surface as well as the area spline. And we do the same thing with the inner shape and the spline of the large assembly. But there are still separate things, like we have a multiple set of points right now, and I'm gonna do some differences in operation, so I end up with one single valid point set that I can work with to spawn the visuals. So the other thing that the first thing actually that we are going to do after sampling the spline is to do the differences. So let
Do you
me
want to talk about the debug settings? Because I think if you enable debug on the demo, it will show you very
Right.
big boxes. Just show how you have these very small boxes to see it better.
Oh, right. I get what you mean. Yes. So on every node, you have debug settings at the very bottom. And you can change the scale method of the points that are going to be displayed. By default, it's the extent of the point, so it's really the boundings of the points, and you can scale those boundings for multiple reasons. Or you can force them to be an absolute value or relative value based on their scale. In this case, I've prepared it so it's like easy to demo. You can also change the mesh. I could go into and change, maybe not that one, but I could change those to like tripods or whatever debug mesh that is useful for me to build the procedural rule. And I can even use the material overrides there. So it's easy to preview something very specific or color something so you understand what's going on. Another useful thing about the debug before I continue, you can right click and go into the menu, but pressing D just enables debug and disable it if it was enabled on the node. As you can see, you can have multiple nodes with debug activated, and that's a transient state. So if you reload the graph in the world, you won't have all of the debug active on each of the nodes. But the other interesting mode is like debug only selected, which is kind of disabling the mode on the other nodes and enabling it for the other selection. So you can go from Control Alt D to another step, Control Alt D, and you can kind of walk through the process here, the execution here by doing so, which is pretty useful. Am I forgetting something, Adrien?
No, I mean
Okay,
that's. I'm always giving you the caveat that it would have been possible to do it without the pre-sampling as well, because you can do the difference like up front. But still, at that point, we were still like, it was easier to do it this way. Now it'll be better, I think, in the future. But
Yeah.
that's it. That's about it.
Yeah, there's multiple ways of doing things there. The goal is to get the most performant one and the one that gets you the result.
Exactly.
So when we built that, we did it that way. So we started by sampling each of the spline again, and then doing the difference. We're also doing difference with volumes that are going to create the entry and exit points of the area, and I'll show you that in a second. But before that, again, here it's,
Moved it.
yeah. Here is the subtracted shape of the large assembly over the surface of the area. And as I just said, we have volume at both entrance and exit points that are calling out the points that would be blocking the path or blocking the exits and entries. Okay, now let's go into here, which is now that we have that surface and we've optimized a little bit, so we've removed points under the assembly. What we wanted to do is to create a distance field or have the information of the distance between each of the spline baked down into the points as a density value and an attribute that we can use down the line to spawn meshes. So we've created the distance node and we've used it with the spline points around the surface to create that distance information and bake it in. As you can see here, in the distance, we have set density, and that's why you can see the gradient on the points right now. Okay, now that's pretty cool. We have the distance from the sides, but it's not the only thing that we wanted to do, because of course the points from the surface are aligned against the surface and aligned against the surrounding spline. But what's going to happen if I spawn meshes around the large assembly is that they won't be aligned properly with that spline going around the large assembly. It would just be considered as a flat ground. So we had to reorient the points that were nearby the assembly to follow along its shape. So if I show the debug here, that's pre-rotation. So you can see that they do follow the spline for the
Orientation,
area, but their orientation, but they won't follow the inner part. And what we're doing here is that we are filtering based on the distance length, a set of points that we are going to reorient against it. So I'm just going to enable that now. And you can see there that the points from about the center up to the inner spline have been rotated to match and conform around it. So now I can safely start thinking about placing objects that would be following the path or following the area, basically.
Do you want to add that the lookat node is a custom blueprint node?
Oh yeah, right.
That you did for the
Sure. So basically, something we didn't really touch about, but we've talked about it before. But you can implement PCG nodes through Blueprint. So if you derive from the PCG element Blueprint class, if I remember correctly, you can basically implement the node yourself in Blueprint. So sometimes it's going to be, you might need to do it natively, but for some purposes like this, where you don't have 1,000,000 points, it's going to be good enough to do it in Blueprint. It's also a lot easier for people to prototype or even develop. See, this has never seen the eyes of any engineers, and it works well. Yeah, and I think maybe something we could talk about a bit more is, the way we've computed values and stored that on the points as attributes, and then we're able to build logic around that. That's the thing GS did in the fourth step is, you compute the distance and then the length of that distance, and then he was able to use that property that we'd written per point, and to be able to do point filtering. So keep the points that are far away and don't touch them, and then just work on the other set and then merge them together at the end. So you get this result.
Yeah, I think I'll be talking about the attribute operation here, so it's gonna cover that. Yeah, so the custom blueprints, it's up for everyone to create. It's kind of like data scripting language, or you can use Blueprint to create your own nodes, and then you don't have to rely on engineering or native nodes implementation. It can be slower, obviously, but it's a very, very good and efficient way of prototyping and making very custom things with the framework.
And just to add on that, it's just that it's very easy to prototype with blueprints, but then it's also for an engineer really easy to convert it to native usually.
Yep.
So if you are satisfied with, if the technical architect is satisfied with the node, you can ask an engineer to put it in C++, and it will usually give a good speed up just by moving the logic in C++.
Yeah, and I think what's best about what we've provided is that it's going to be the same interface. It's the same. The nodes are not going to be different. You have the same kind of control in the pins. You can have overrides like you would have in native nodes and so on. So it makes for a very seamless experience when you use Blueprint nodes.
Cool. Okay, so on to the attribute operations, and that's something that we've used a lot. So as Julien just talked a little bit about, on the points, we can store the attributes or access the properties of each point. So pressing A or going through here and toggling in the inspection within a context. So you have to pick your context. Right now, I only have one blueprint in the scene, so I can just use that one. You'll have all of the properties that comes with each point, but also the user created attributes that were added to each of these points. So here, the good example is that we're basically copying in the attribute operation, we're copying the density property into a new attribute called edge density. So I'm backupping the value here. So it should be, if we look at density,
Should be the
it
same.
should
Yeah.
be exactly the same in edge density. And then what's interesting there is that I can do a lot of different operations. If you look for attributes, you get like Boolean operation, mathematical operation, partitioning if you want to separate your data based on one specific value, rotators, transforms, trig, and vector operation. So there's a lot of things you can do, and it's not only adds and subtract. Like you have a lot of things that you can do in there. And it really feels a lot like working with a material or doing some shading and or vertex shader. So it's really interesting to manipulate the points to do something that you'd want to work with, and you'll get a few examples there. So the first thing is I'm backupping the edge density. And then I'm creating a small offset in Z. So if I, maybe I can, it's going to be easier if I pick the same debug view here. Okay. So you see that from the position Z of each point, I'm adding 10 centimeter and I'm writing it to the position Z here. So that's why we get some 10 centimeter transform upward. Then the goal is to create a carved riverbed. So the spline surface was flat and all of the points were aligned on the surface. If I look like this, they're all aligned, and that's not really the riverbed shape, right? So here, what we're doing is that based on the edge density, so the distance from the edges that we've backed up in that value, in that attribute value here, I'm multiplying the distance with 125 centimeters. So the points that are at the center will be lowered up to 125 centimeters, and the points that are at the edge won't be modified at all. So let me debug this node here after being subtracted to the position. So the multiplication, I can maybe show you the edge density value that has changed. So now it's not the density value anymore, it's 125 multiplied by the density value. So I've stored the offset that I want to push into the points here. And then I'm going to subtract that value to the position. So if I go into position and I switch between previous, well, that's a scary number, and enable the inspection of the subtract, we get lower points based on the distance to the edge. Cool, and that's creating the curved riverbed shape that we are looking for before spawning assets on it. Okay, great. So from this point on, we have our set of point, and we're going to reuse that. We've prepared that set of point to spawn a bunch of meshes, and that's where we're heading. The first thing is we wanted to cover the rock around, again, the splines. So something that we're doing very often is that we're using density filter just to let me look like that. So we select the points from the density filter here. Then we noise it a little bit, just so we can like filter, add random rotation or filtering or transforms. And then we get into spawning. So disable debugging. Now that we're heading into static mesh spawner, we can see that we've started spawning the meshes around the area. But that doesn't cover the ground, right? So using the same approach, so now filtering the center points and then removing the points that would overlap each other to avoid overdraw as much as we could. And then applying transforms, we get to filling the middle section. If I remove the rocks, we get somewhat curved, very like small, like gravel, sand kind of thing. And we have the rocks, whoops, not the right rocks. We have the rocks around it. And the good thing is that they're following the shape on both sides. So that's all of the work that we've done previously. Okay, and then we can start on, and that's too simple visually, so we can start on adding, using the same concept, so density filter, density noise, and transforms. We can start adding more and more details up to getting the riverbed that we wanted. So far, so good. You have anything to add there, Julien, either?
No, I think it kind of shows like the data prep phase where you're gonna spend a lot of time doing that, and then you're gonna just tweak the visual results when you create the artifacts at the end. Yeah,
exactly.
And you know, we don't talk about it a lot, but there's a lot of caching involved to make stuff faster as well. So you know, if stuff earlier in the graph hasn't changed and it's not creating creating visuals or something like this, most of the time we're going to be able to reuse something we've already pre-computed, so it makes iteration a lot faster.
True, it's extremely important.
Yeah.
Okay. Before going in the middle section, we have another sampler with the surface of the spline. And that's interesting because we can spawn from that very tiled sampler or water planes to cover the area. So we start adding the water planes meshes, and we do the same kind of thing with set of points for decals. So we're adding decals in the world using the spawn actor node in this case. So and if I pick the ground at this point, you'll see that not only I have a bunch of ISMs, which is all of the visuals with the collisions, but also a bunch of vectors that were parented to my ground blueprint here. And these are all decals that we've spawned underneath the water there. Okay, let's try to, I'm trying to go fast because there's a lot. The next thing is,
It's only the first
I've,
graph.
yeah, I've removed the assembly there because, well, you could be satisfied with what's there. And the good thing is, like, this is an area that you could build on. You could break the procedural, and that's something I can show. So on the component, you have an option, which is hidden right now. You have an option that says clear PCG link. And what is that doing? Well, it's just going to break the link between the procedural graph and the asset that it was spawning, including the actors, and put them directly in the world like any other actors. So you won't be able to regenerate the procedural results from that point on, but you'll have access to all of the meshes that were spawned or the actors that were spawned, and then you can modify those manually if you want.
Yeah.
The other interesting aspect there is that, okay, you have the base ground to work with, and nothing prevents you to start adding manual objects and instances on top and creating your own area. You can take the exclusion zones, and like you're not satisfied with a section, you can move the exclusion or add a new exclusion and create your own little area there manually if you want. There's no problem with that. We encourage everybody to mix and match procedural and grafting and traditional workflows, and that's what we really aim for, like not being in the way of the artist, but really being something that helps production, helps well building, but always considering that and grafting is extremely important, and the visual result is the most important thing there to respect. Okay.
And the perfs.
And the perfs. Okay. But during the demo production, we wanted to have this section fully procedural, so we've added another section using the same concepts again. I'm not going to go too much in detail there, but using the same surface points that we're filtering and doing some density operations, we get to spawn a few assets and assemblies there. And these will be removed because there's a long line there and a difference node. But all of these points that I've shown are being removed by the large assembly when it's in the world. So when it's not, the points are there, the asset will spawn. When it is in the world, the points here are going to get removed, and nothing will get spawned. And that's why when we drop the assembly in the scene, this is going away dynamically, and it's being replaced by the assembly that you've placed. We're doing, again, the same approach here with the dead trees on the floor. So it's just adding more details around the environment. And the last thing, we also have rocks. And the very last thing, which is quite interesting, is the clover. We place clover on what we created. And if you follow me here, is that since we're a data flow graph and the execution could happen mostly at any time, there's a problem there. If we were to spawn those meshes before the rocks, it would end up across them or underneath the visuals. So we need to do something here.
Yes, to be clear, is when you're gonna do the raycast against the physics using the world rate query. If you know the other meshes haven't been spawned yet, well, they're not going to be there. They're not going to block the raycasts. So you're going to get your clover under, well, under what you would expect, and so on. So basically, if you create a dependency, like a data dependency, even if you don't consume it, it'll make sure that the things are executed in the proper order.
Exactly. The dependency here was created with a gather node. So every end point that we require for the clover to be there, we've added them to the gather node, and then we're filtering only the points that we need to continue. So it's really the gate or the bottleneck, I would say, here for the clover to be spawned. And what I'm showing on the screen right now is the clover points that we want in the world before being reprojected on the surface of the meshes that were spawned by the rule. So as you can see, they're going through everything here because right now it's only the points from the spline surface. What Julien was
Which is a flat
mentioning,
thing.
yeah, it's a flat thing. So what Julien was mentioning is the projection and the world read. If you want to go into detail there, I'll let you explain it if you want.
Basically, I mean, the projection here is going to take all the points and project on another target, which in this case is a surface. It's somewhat 2.5D surface, which is the physics world with the raycast. So basically, we're going to take all the points and we're going to recast from the top of the volume down and find the position and update the position for every point. And there's a bit of settings there. You can decide whether you're affecting rotation and stuff like this, but that's the gist of it.
Exactly. Okay, from the projection, that's great. We have a lot of clever or potential clever position, I should say. But the thing is, the clover that we spawn here, let me disable debug. Clover patches that we spawn, they're really like 50 by 50 centimeter patches, and they can end up being like pushed on the top of this rock or like next to this this edge here. So they would extend and be like floating midair on this part. So we had to find a way to detect flat areas within the world, and we came up with this solution, which is a subgraph that is called discard points in bumpy areas. Sorry for the name. I'm not gonna say who picked that name. It's not me. But
Very
let's call it
straightforward.
let's call it flat area detection subgraph. Is yeah, well, and going inside this graph, I'll try to show you the best thing to look for in the process. So for each point that I've created to be spawning clover patches, what we're doing is that we are creating 4 additional extra points. So based on an extent that we want to test against. So that's a setting for the subgraph. And we're placing those extra points at the corner of based on the center position, which is the point that we want to spawn on. And we're testing against a plane. So the plane here is representing the area of the point we want to spawn. So the clover patch in this case. And then the 4 points that I'm talking about, the 4 extra points that we're going to test against, we're testing against the overlap between the area of the point and the extra point. And that way, what we can do is if they don't overlap, it means that there's a very good chance that there's a height difference or it's not a flat area. It's not a flat area flat enough within these bounds or the blue bounds to spawn the asset. So we're finding the position that are invalid, and then we can discard each of those points individually from that information. And the good thing is, since it's a subgraph, well, it's mostly using, I think, native Node, so it's not the most performant thing because it has to do some projection in the world, but it is still very usable and quite fast. And we can apply it on such amount of points, but we can use it in the forest as well for larger stuff on the landscape. It's not only for the clover patches here, but it could be houses or finding places where you could place like much larger things that would require a flat ground. An additional thing that we're doing as well is that we're testing the normals of the extra points and the point that we want to place to find places where there would be a cavity in the middle or a bump. So it's not only the position, because you could end up with a valid point if we were to test only the position. We also added a test based on the normals, and then we're getting extra points to invalidate. Okay. And after doing that, we can get rid of all of the points that would be spawned at the wrong location. Great. So that's a lot for the ground, but it's the real basic of everything in the demo almost.
I mean, it really shows the interaction between the multiple splines, the multiple data sources, and then the way you can compute as properties, and then build some logic around it and build something that's relatively complex.
Okay.
Now, before we go to the forests, any questions?
Yes, I've gathered a few that I will be tossing your way. Before I pull those up, did want to let you know that first, everyone is very, very impressed with how organized the graphs are. That's hitting a lot of points with everyone.
I think it was the fear of showing it in public, but I'm kidding. I'm sure these guys work super cleanly most of the time. So
we try. We kind of knew at some point that we would be sharing this. So yes, there's the desire to be easy to follow and like, because it can get complex, but like again, as I've shown there, going through step by step and having the clear organization helps out a lot when you look at such a complex thing. So.
Yeah, I think between the debug display and the inspection, it makes it much easier to follow through and see what happens at every step.
Yeah, it is effort well appreciated for certain. Yeah, I've got a few questions that I'll toss your way that seemed a little more specific to this section. The first one is from Shamikaze, and they are wondering, can this new PCG tool do anything like structures as well, or is it something that you feel is mostly suited for landscapes?
Well, we haven't shown it. Maybe GS, you can talk about it because you maybe played with it a bit more. But we've had prototypes internally where you can start from a spline, build the building footprint, and then you could just simple points and then duplicate them and then build logic around that and stuff like this. But yeah, would have been nice to showcase that, but there's choices to be made in the forest, so.
Yes, we've very early on. That was one of the first thing that we tried. Like we built like a few building prototypes, and we're still building prototypes right now because there's different approach that we want to test and make sure that it works with the framework. But I think it's possible right now. I'm not gonna say it's easy, obviously, because you need to be like using the attributes and maybe some custom nodes there here and there. But the end goal is to be able to do any world building tools. So it could be a building, it could be up to a city, streets, or a forest, obviously. But another thing that doesn't come up often, but we're really aiming at runtime, and like you can see that we're aiming at runtime while editing, so live editing. But all of this, everything that I'm showing is also working at runtime in game in the cook build. Like you can start thinking about generating environments that were not pre-cooked, that were not saved in a level, and that would be generating live in your game. It could be very small around the player or based on an event or something that happens in the game or in the at runtime. It could be bigger as well. We've done like 2 kilometer worlds swapping style as we were playing, and it was kind of working pretty well. And surprisingly,
Yeah. With a bit of smoke and mirrors, I mean, it's reasonably easy to integrate in the game or something like this if you want to change, like do big changes.
And what
and
seems also
everything.
interesting. Oh,
Oop.
yeah, go ahead.
Sorry, everything that we're doing in the coming like releases is to make that like easier and easier to work and to build. We're gonna introduce hierarchical generation, so at runtime you can like build much more complex stuff live. Eventually GPU gen. Right now everything is on CPU. And so on. So like it's really something that we care about and we want to push in the future.
Yeah, and just to add on the runtime stuff, it's we aim also to be deterministic with the PCG. There are tools integrated into the PCG editor to see if your graph is deterministic, and with that you can use it. You can generate PCG stuff on a server, or each client can generate PCG, and it's replicated all the clients. And with the determinism, you are assured that everyone will have the same result. So it's not just runtime for single player. We can also aim for runtime multiplayer with replication.
Yeah, I mean, that's a good point. And I mean, as soon as you want to have like dynamic levels or general levels generated on the fly, it's gonna make it a lot easier for games that want to do that in a multiplayer setting. Yeah. And determinism is a important thing in general, just because you don't want to go in the editor and bump something and everything changes, or let's say you're doing some animations or a cutscene or whatever, and you don't want it to change, like if you've prepared your shot and so on.
Wow.
Any other questions?
That's some incredible potential impact there for future projects, for sure. I have one more question that I want to throw at you for now. And then don't worry, everyone. I still have your other questions. I'm just saving them for a little bit later. But this one I feel like is appropriate for before we move on to the next section. Jackson Hayes was wondering, is it possible to instance out a mesh to make it editable or replaceable? Since obviously you're making a whole bunch of generated content all at once, and now they're curious about kind of going the opposite way. Is it possible to take individual pieces and either bake them or edit them and move them out, or is it best to keep everything kind of within the splines and the generated systems?
I was going to say, maybe I guess it kind of, maybe I didn't understand the question correctly, in which case, please correct me. But, let's say you've taken, I guess just gave the example, you can break the PCG link, and then that becomes like a standalone asset you could use somewhere else in your game, whatever you want to do with it. Basically, we're just going to build the aggregation of the thing, and then, it becomes an actor like anything else. So you can do more with it.
You cannot move like the meshes individually, since there are all instances.
Well, they're in ISM. No, I think it's possible. So yeah, shouldn't be a problem. Yeah.
Very cool.
Maybe we'll get there too.
Yeah, there's a caveat, obviously, as I probably said or hopefully said before. If you use the clear PCG link, it's a destructive step, so
Yep.
you won't be able to regenerate and just ignore the thing that you wanted right now. It's kind of like a wish to get to this point where you can pick one thing and then exclude it from the procedural generation while keeping everything else running and working. It's again part of our goals, but it's obviously not an easy one to realize. So we're going to keep on working on that.
But you
Okay.
can also see that the during the demo you have the encrafted part. So if you decide that this part should be encrafted, you could just set a volume with a difference. Everything is generating around, but this thing is excluded from the generation, and then you already scan and craft and place all the meshes and actors. And it could also be blending with the logic after. So you have also this possibility to use PCG for like the mountains and everything, but the center of the play game uh, is done is with
Could
it
be
handcrafted.
encrafted.
So.
Yeah. All
Awesome.
right.
Cool.
So
I jumped into the PCG spline example world for one specific reason, is because the rest of the things that I want to show really mentions like and uses the assembly workflow.
yeah.
So we came up with something during the production of the Electric Dream sample or demo that we wanted to leverage all of the assemblies or groups of assets that were placed and created in like really good looking again um, into the procedural system. So it's really mixing the input, which is manually crafted, with an output that is procedural. And here, it's a single level instance with a very small setup here that wasn't crafted. Each of these things were placed manually. And from that content, we can export it as a point cloud and then use it in the procedural role. In this case, on a spline, where it's only everything that you've seen on that you see on the spline here is it's just that thing being rotated around, filtered, and it
Place
just looks
multiple
more
times. Yeah.
placed multiple times, but it looks still credible and it works at like, various angles along the way of the path. And it's extremely easy. I've documented how to use it on the official documentation, so you can look at that. But let me show you very quickly. So I'm just gonna edit the level instance here, and I'll add just a few more trees around it. And I'm not gonna really care about the visual for the sake of time. I'll show you that we created an utility. So under PCG utilities actor tagger, there's an editor utility widget that you can bring up while doing this. And you can tag assets with this utility very easily. So you could add like a tree tag to all of the trees that you've added to this world. So I'm just gonna add the tree here. And what it does is that it adds, did it? Okay, it adds an actor tag on the selection, which was a tree in this case. Okay, and I'll just save that modification to the level instance. And since it's a level, I can use the utility that we provided with the plugin. So if you go under scripted asset action utility on the level, you can convert it to the PCG settings asset, storing the point cloud that I was mentioning. So now I've just updated the PCG settings. And in the graph, we have this PCG settings, which points to the asset here, with a set of points. So if I was to debug and inspect the points, you could see all of the meshes that were originally in the level with all of the materials and meshes, soft object path, written as attributes. There's even a hierarchy relation and relative transforms and everything that we want to keep, and also the tags. So right now I have keep vertical. I'm gonna force refresh the graph here using control click on the force region. This is invalidating the cache and forcing a refresh on the system. And you can see that all of the trees that I added were also part of the new refresh and the new procedural graph here. So if you get the idea, manual handcrafting, nice small setups, tagging, actor tagging, and then procedural on top to augment the manual assemblies by applying rotation, transforms, filtering. I could remove the trees now based on the density noise or based on height or distance to whatever. So it's really an interesting workflow to mix and match procedural and crafting there.
Yeah.
Okay.
So normally that's paired with setting instances, so you don't do full copies of the points. So you could use it multiple times. It's just gonna keep one copy in memory, and it's used a lot with the copy points node. So you'll see it very often. And so the copy points node basically creates one instance of some set of data per point in the other set of data, according to some rules you can set up. So you can build these, you can take one point, spread out, and then for each point, place the kind of assembly, and then you can do later processing on it.
I've opened the PCG large assembly level, which is another breakdown level that you can look at. Very lightweight, and in this level, we've added the assemblies that were used to create the procedural assembly on the right side. There's reasons for those to exist. So there's the placement of the assemblies is based on the spline curvature. The smaller modules would be placed where there's a high curvature on the spline, and they are 360 modules. So they can be virtually rotated and placed anywhere when there's a very steep curve or a spline curve on the assembly. And then the longer pieces and like landslides are used where the spline is less or more straight and less with less curvature in there. Then we have the fallen tree asset that I'm gonna cover in a second. Okay, let's head back to the close range again. And dig into the large assembly quickly. Okay, yeah, right. Open up the graph. So another graph. Again, don't be scared. Just gonna disable the spawner by pressing E, and I should have no more assembly visible. And the first step is to find the high and low curvature points that I was talking about. So here we symbol the spline, and then based on the curvature, we write it to an attribute, we filter them out, and then we come up with the points that are on a low curvature or high curvature. In this case, it's a low curvature point. And at the bottom, we have the high curvature point where the spline is going around the corner. From these points, then it's easy to, as I said, select the assemblies to spawn because we know, like, okay, it's flat or it's curved, and we can get into. Let me find my way here. Up to a point where, after defining those points, we can spawn the assemblies that we created manually and store it as a point cloud, just as I've shown with the spline example, and end up with the placement of the embankment around the large assembly. So you might recognize already the modules that I've shown in the other world. Okay, so that's the very first step. And then we go up to here and we try to build the surface here. So it's very similar to the ground. So we sampled the surface of the spline, and then we change the extents of the points up to transforming the points to the level of the wall or the embankment wall surface here. And from there, again, using assemblies, so there were very small assemblies, we could copy those assemblies on these points, apply some filtering, noising, and like parameters, and spawn the surface of the assembly. And
I'm gonna make a small parenthesis. Is one thing that's very important here is that since we've taken the data from the assembly, in which we have the mesh written to an attribute, we're able to spawn the mesh according to that attribute. So if you earn a static mesh spawner, if you pick by attribute, you're gonna be able to say, okay, I want to spawn this mesh, so we're gonna take care of the loading and everything.
Right. Remember, I've shown it in the spline example where the mesh is written as a soft-object path here, and even the material, the first ID. And as Julien is saying here, if I go into the static mesh spawner at the very end, it's not using the mesh entries within the static mesh spawner. It's using the attribute called mesh, which is what was stored here, mesh, and then the visuals corresponding to that attribute for each point is used to spawn the visuals. So that's why we end up with assemblies being recreated and recopied over and over on different points and being spawned by the system. Okay, let me go to something very, very interesting. The fall entries here. So I'll enable all of these nodes. These are in the sample, and you just need to enable that like pink box or command box. All of the nodes that are in there will show you this debug display by enabling it, and it really shows you how we've made the fall entries logic for the large assembly. So as I said in the very, very, very beginning, the large assembly is dependent on the ditch spline and the ditch wall, and that's the reason why we are defining if the fall entries should be spawned or not based on like windows that are scattered around the embankments. So you can see the larger squares here or windows. These are like potential fall entry target position or targets. And on the assembly, we have potential fall entries volumes that we test against the windows. And if there's a collision between the window and the potential fall entry, we decide that there's going to be a fall entry there and how it's going to be placed. If it's colliding with the very last box here, as it is right now, it would be a fall entry that is pointing down like 45-degree down because it's just a little bit too far to be on the surface. But if it is going through the window with the first box here, it means that the distance between the assembly and the side is small enough that we can have a fall entry that goes across both sides and be like horizontal in this case. So let me re-enable the fall entry visuals here. And you can see that it's the horizontal, like it's a little bit off, but that's for visuals, right? And we have, well, this one here that was colliding with the last box here that is pointing down. Same on the other side here. So it's pointing downward instead of trying to be at the surface like the one on this side. If I move this assembly left and right again, you'll see that now the target is, or the window is off range and we don't spawn the tree. If we move it back inside, we spawn the tree. And if we end up moving it close enough, it's gonna be horizontal instead. That's how we build the logic for the fall entries. And we could control the amount of potential windows and the amount of potential fall entries, so we can change the distribution and the overall look with that. Hey. Oh, right. It's different. Disable this. Now, the last thing for the large assembly, I think, is the cliff structure. Let me.
Oh, the large structure. Yeah.
Yep. So that's the large cliff structure, right? That we're spawning. Again, it's an assembly that we've exported as a point cloud and that we're copying. But the interesting bit here is that we're getting the actor, and the actor is actually spawned as a child actor from the large assembly. So in the large assembly, you have a cliff helper child actor, and that's what we're getting in the graph. And its position will define the position where the large cliff is being spawned on top of the large assembly here. And as you can see, it removes the fall entries by the procedural logic that was built in the graph. It would also remove the trees because I've not enabled them now. But let me re-enable everything. So there's trees and then there's more. If I think I forgot one thing here. Right. Okay. So if I keep on moving this thing, it's just removing the trees around it and taking the space. So it's always coherent and it's always working. Great.
Right.
Cool. And for the close range, I think to end with the close range, the embankment walls on the side, they're really using the same concept. So I'm not gonna go deep on this rule there, but it's using the same concept where we have assemblies that we're exporting as point clouds, and then we're building the point data along the spline, find the right position for each of these assemblies, and then spawn them. And we can do that for the wall, but also for the surface behind it, and even the trees and the additional details like this, like rock here, which is another assembly. Yeah, so this is pretty much the close range. And it took much more time than I was expecting to go through this.
Yeah. Still very interesting, though. I mean, it does kind of show in a very tight spot, the amount of complexity you can have. So, yeah.
Yep.
Yeah, absolutely. Lots of use cases for stuff like this, especially for smaller projects or smaller games, being able to utilize the tools still in something that's not necessarily a huge, massive open world RPG, for example. There's still some really applicable uses for these tools, and I think this was a great way to showcase that.
Yeah, and I'm gonna spoil someone, but it's reasonably easy to pick up PCG and build other kind of you know not standard tools, but things you've seen before, like uh, square, well, cube march and stuff like this, marching cube, sorry. And you could do wave function collapse. You could do a lot of things to like keep in line with what you want to achieve, but still keep like it's super iterative and easy to use.
Yeah, absolutely. All right, well, I want to make sure that you have time to move on to the next section. So I only have 2 questions that I want to toss you all's way. The first is from Freak Hoekstra. I really hope I said your last name correctly. My apologies if I did not. But they're wondering, what if the shape overlaps with itself, as in some sort of overpass-like situation?
Right. I guess you could do a diff of yourself, but that's something, for example, that was something we had a problem. Like, let's say you want to do the distance against yourself, but not your own thing. Especially for points, that's something where we fixed very recently, but I don't think it's in 5.2. But um, yeah, I guess you could do something special if you wanted to. Yeah.
Yeah, you could also, I think, build like a set of points. Like I've tried something
Right.
like building a roller coaster.
True.
Like so you could build a set of points for the shape that you have, and then when it's intersecting, you can use the same set of points with different bounds, and then try to exclude the overlapping points there to prevent spawning like a pillar in the middle of the track in the case that I was experimenting with. But yeah, I think you can reuse the set of points with different extents, with different transforms, to use them as differences or unions or intersections before spawning your content. So there's ways to manage like the overlaps. I don't think we've managed that in the specific large assembly tool. If we were to do like a 8 shape or like crossing over, I don't think it would perfectly work. But I think there's ways to manage it.
Yeah, I mean, I'm not sure that the spline sampling when you have 8 shapes would from the interior would work well either, right? But you could certainly work around that.
Yeah, definitely feels like there's a lot of adaptability possible with this. And then second question I had for you is from Zenthorx, and they were wondering, given runtime generation of surface, isosurface extraction, for instance, any suggestions to use runtime surface as viable inputs for PCG? And can we avoid using collision meshes?
I mean, if you're able to write in PCG you can easily derive classes, and not from Blueprint for data types, but at least at the moment you could easily do it in C++. You could create a new type of surface. There's a very simple API you need to implement. Like there's a sample point method that asks you, is there a point there, or there's a projection method, and that's basically it. So you could definitely, implement something for ISO surfaces, or something that you would do for simulation purposes or something if you wanted to. Yeah.
Awesome. All right, that's all I'm going to toss your way for now,
Okay.
just to make sure you can still show everything you brought us.
Great. Okay, let's jump on the mid-range larger stuff. Do you want to say something, Jay? Or?
No,
Oh, oh,
because we need to go. We need to
okay.
go on. Yeah.
Okay, great. Okay, so what I'm showing here is partition actors, and it's something that we support and we haven't talked a lot about. The forest rules. So we have like a cliff, mountain, forest rule, and then the base forest at the very base of the world. These two rules are partitioned into different partition actors in the world. And this is a choice that you make on the component. It's not within the graph, it's really on the component. I'll show you with the forest graph. And where you set up in 5.2, because that's going to change in the future, but where you set up the partition actor is on the PCG world actor here, where you have a partition grid size and 2D by default for just the sake of the amount of actors that it would create. And we've chosen 512 meters for the demo because that was like giving us the good performance that we wanted. By default, I think it's 256 meters, but you can mess around a little bit with that and change or find the proper granularity of the partition actor based on your performance that you're looking for. But the concept here is that the graph is going to execute on each partition actor individually. So it's still managed for the technical artist or for the person working on the graph. It's still a single graph. It's still a single actor, a single source actor that holds the component with the graph. But the fact that that component is partitioned, it's going to be copied over on the partition actors, and that's where the execution will happen. So on each partition actor, you'll see the end results or the artifacts being produced. So in this case of the forest, the partition actors are the ones holding all of the ISM and ISM component, and they would be the ones with actors if I had spawned the actors in there. And if I look at ECG demo forest, there's nothing in there because, as I said, the component here, the PCG component, is under advanced partitioned. And the graph can run on not partitioned, but it can also run partitioned. So it's something to be aware of
Aware of,
and try.
yes. Yeah, basically, it's kind of a feature we need to do as well to play nice with world partition for multiple reasons. First, I mean, you don't want to have a like 5 kilometer by 5 kilometer actor. It's going to be terrible for streaming. So that kind of takes care of that for you. You know, like the simple trick is that instead of passing you the whole volume as your input, it's the intersection of your volume plus the actual partition actor, but small details. So we're taking care of that. And for most intents and purposes, it doesn't change anything except in very rare cases. And it's also faster, and it's gonna be better for streaming. And if you were to generate at runtime as well, you could generate on load. So you generate just by sector when these are loaded. So you need to generate the whole forest, for example. Um, yeah, and this is
Yeah,
something we're still working on. Like this is going to evolve a bit over time, but yeah.
when the Julian said is faster, it's just that since you are generating on a smaller volume, we leverage time slicing. For it means that each volume will get generated one after the other, and instead of the one in big volume. So if you are working on 1 million points, for example, it can take a lot of time for spawning 1 million meshes in one frame. With time slicing, you are reducing the number of points you are generating in one volume, and each task will be generated one after the other. And if there is not enough time remaining with time slicing, it will wait to the next frame to continue generating all the meshes. So you will have more responsiveness with partition because you are working on smaller volumes.
Right, and we're also able to do like culling. When you do queries against, let's say you want to find splines in the world, and you call against yourself. Well, since you're going to be a smaller volume, you get less things, then you have less work to do, and so on. So there's a lot of optimization that goes in there.
Okay.
All right.
Cool. Quickly, the PCG demo forest blueprint. Again, we're instancing those in the world, and it's pre-configured, preset in the blueprint before. So I have a box that is covering my world. It's like I don't know, like 512 extent, so 1 kilometer, 1 kilometer in that case. And a PCG component which has the graph. So the PCG demo forest graph, and the default one is not even partitioned, so it's not enabled, and I'm enabling it on the instance in the world based on the world I'm working in. The important thing here that I want to talk is that, as we said at the beginning, we can expose graph parameters from within the graph now, but when we built the demo, we didn't have access to this feature. So we created variables within the blueprint. In this case, there's a bunch of global variables to control like tree density, tree scale, rock density. And that's what we were showing in at GDC, like we were changing the values and it would update the forest. But we've also created a structure here. So let me show you the demo, the forest settings as a set of settings. And this is what we're getting in the graph again to set a bunch of parameters within the graph and overrides. And the cool thing with that is that we used it as a preset. So if you were happy with one of the setup that you've built and tried, you could store those values in the structure in the blueprint and then apply it on the fly. So you could review two different settings, or you could use it to change dynamically as we were showing. And in the graph, how does that look like? And that's probably the most scary one.
It is scary.
We're getting the actor, so the original actor in this case, because we're partitioned. I want to make sure that I'm getting the source actor. I'm getting the current setting structure, and then I'm filtering which attribute I want to override with. So these are user-facing parameters, so eRow trees per square meters or the eRow tree spacing. But in fact, they're changing the surface sampler or the density filter values or the density noise or the normal to density parameters. So we're really using that as a setting file or setting asset, and then we're applying it to the graph as overrides for each of the nodes that would make sense to override.
Can you show the inspect of the get actor property to see what you have for the structure?
Yeah.
Yes. And that's interesting. So if I inspect the get actor property, since in the current world, my component is partition, we have multiple contexts. We have for each partition actor a context, and we can inspect for each the content of each node. So in this case, that's the structure I got from the actor with all of the values for that settings that I'm getting. And that's what I'm filtering basically to get one entry per override. So eRow trees per square meter here is that value that's going to be used within the surface sampler for the eRow trees. Okay, let's go and do step by step here. I've disabled all of the meshes, and I'll be going very quick because it's the same concepts that repeats from this point. We've instead of a spline where we have the landscape in this case, so we can like sample on the landscape different sets of points, and the first thing that we wanted to do is the rocks, because the rocks will be used in the difference for the trees, so they don't overlap. We don't have rocks going across trees. And let's debug this thing. That's all of the hero rocks and rocks that we were going to place, and I can enable the visuals and debug. So these are the very basic rocks. And I would call those primaries. Like in procedural, there's often this concept of like doing primaries, secondaries, and tertiaries around assets. And so these would be the rock primaries. And using the copy point solution that we've used with the assembly, so copying the point data on another set of point, we can create secondaries here. So from all of the rocks that we've spawned, we've imported a data table, which is a set of points, just like an assembly, or we created a grid, and we are copying those source points onto the target rock point to create secondary and tertiary assets. Again, same concepts, density, noise, filtering, projection against the landscape this time, because we want them to be projected and sitting on the surface of the landscape. So we're using the projection node here. We end up with spawning those additional secondary points. So let's disable the debug and enable the visuals. So here we have just like a lot of rocks. And from the primary, we have the secondaries, and we have more details around them. Now let's go up and go into the trees. So the trees, it's the second thing to look for in this graph. You can debug the first set, which is the hero trees. So that's the most like pretty larger, dense trees that we're going to place. And then we have another set of smaller potential trees that's going to act as secondaries or filling around the most important ones, or being used within the clearings. The clearings here is a very low like density surface sampler on the landscape. And each of these points are considered to be clearings within the forest. So we're building a distance, again, using the distance node as we've done with the ground previously, around the clearings. And from that information, we're defining for each of these points what should be spawned. And since it's a clearing, we should spawn like lower assets, like very small saplings and bushes and fern, compared to the remaining points outside of the clearings, which should be filling trees. Okay. Yeah, that's with the clearings being removed from the secondary points. And then we go up to spawning the trees. So spawning the hero trees here, spawning secondary trees and secondary assets around the hero trees. We have like rocks and different roots or ground patch objects that we're spawning, and more, up to spawning the secondary filling trees in this area. And what's left over, as I've said with the clearing, is then be using again the same logic. So based on the distance from the clearing edge, with some noise and density filtering, we can start adding a lot of stuff in that area. Okay. From this point, it's not enough. Like we wanted to have even more assets to be spawned. So we did just like the rocks. So as I've shown with the rocks here, with the secondaries, we've used an import data table, which is a set of points around a disk. And we've copied them over each individual trees in the scene. Do the projection on the landscape again, and we're spawning the tertiary grass around everything else. So it ends up giving us like a quite dense looking forest, which is all parameterized from the blueprint as I've shown with the structure and the global settings. So the global settings here, tree density 0.1. I'm impacting the surface sampler, and it's updating each partition actor live. I'll need to bring up the large cliff density to show you the last part. Disable. That's why you're not seeing anything. Okay. Large cliff here. There you go. Okay. So we have a set of potential large cliffs that are actually picked from the clearings and the trees, secondary points. So we try to position the large cliff structures within the forest just around the edge of the clearings. So we don't have them spread out like in the middle of nowhere, but really like try to place them where there would be less things and more coherent once again. Okay, so these are the potential large cliffs, and then a very similar strategy. We use the density from the density noise, and we're doing filtering on the density to do some transform on some data set versus the other data set. And then we pick which large assembly which assembly or large cliff we want to spawn and copy over those points, which ends up giving us this copied set of visuals that we are spawning by attribute, just like the large assembly and the ditch, spline. So similar strategy. I'm just gonna get rid of that. Similar strategy here, but at a much larger scale within the forest environment.
All right.
I think that's it for the forest.
That's basically it for the forest, yeah.
Good. Do we have questions?
Yeah, there's one here that I did think was kind of an interesting way to address it. Turning Cog was wondering, is it better to deform a plane or convert a small landscape mesh to static when building small pieces to be level instances used with PCG?
It would need to be visuals. Like we're not reinstancing landscape. So every visual asset that we spawn has to be a static mesh, or it cannot be a landscape right now.
Yeah. Now, whether in your level instance you need a ground or not, I guess kind of depends on your use case. Because most of the time you're going to end up reprojecting on either the collision or on the landscape. And something we didn't say, but that might be useful sometimes, is that when you sample from the landscape, if you have edit layers, you automatically get by default the weights of the layers per point you've sampled. So sometimes you can build logic around that as well if you've let's say painted some biomes or stuff like this as well. It's not something we used, I think, in the Electric Dreams demo, but something that is available as well.
Awesome. All right. Well, I have one question that I'm holding on to for the very end. So I wanted to make sure first, was there anything else that y'all wanted to run through?
Do we have time for that? Because yeah,
It's up to
Yeah,
you.
I think that would be the last thing I could talk about because we've mentioned it earlier again. The encrafted area here is what's within the red spline, and what's what's within the white spline is the close range area, and both of these are used within the forest graph to exclude entirely the procedural generation from these sections. So we don't have an overlapping forest with what the artist was building manually. So there's no conflict there. We don't want to fight between procedural and crafting. So it's a very valid way of like mixing both once again and excluding procedural where there's no need for it, and you want to really polish an area or work on an area that is more important but requires encrafting. So, yeah.
Awesome. All right. Well, then, if that's the last thing that you can show for today, I have one final question that I want to pose to all three of you. And that's with PCG, being considered an experimental feature and tool right now. Is there anything or any way in particular that you would like to see this tool being utilized by the public for experimentation purposes? Look, do you want people to go out of their way to try and break all of your hard work and then see how you can fix it? Or are there certain use cases that you hope to see particularly utilized by the community and people who are getting their hands on it? What do you think is kind of the best way to approach it?
I can go first. Well, I mean, it's going to be very easy to break. No, to be serious, there's a lot of things that actually work relatively well, but of course, there's some bugs and more things you'll be able to break for sure. But if you want to have a look and try to extend what we're doing, like new nodes and blueprints and stuff like this, that's something that would be that is already possible. But we're always looking for maybe feedback on the API and stuff like these things that would be easier. But one thing I would personally like to see is PCG used in gameplay situations, like fully like doesn't need to be multiplayer, but it would be nice to see like actual like runtime examples, because that's the way that's where we want to go, just because it opens up a lot of places and opportunities. But yeah, it's my take on it.
Awesome.
Yeah, I fully agree with Julien there. Like, I really want to see like gameplay use case, runtime use case, and people just like building smaller tools, or like it doesn't have to be such large things, but really helpers or tools that improve productivity and iteration speed overall. But like, go in there and break it really, like, just like, and we're monitoring the Discord. That Adrian is there all the time answering
Yeah.
questions. So we're really keen on getting feedback and really like keen at seeing things being built with the tool. So
Definitely. What about you, Adrian? Any thoughts on what you'd like to see?
Yeah, I know that since it's a new tool, there is a lot of things to learn again. It's a new editor, so new way of thinking. It's kind of a mix of material editor and blueprint editor. So any feedback on the usability of the graph editor, the PCG editor, is great feedback, because we developed it internally with programmers and technical artists that were using it. So we were really hands-on. We're like, everyone was into the editor, so it knows exactly what it was doing. And it's really useful to have a new pair of eyes of people that are perhaps less technical and they want to, and they don't understand what is going on, which is, I think, that's a big problem sometimes in PCG, that you don't understand why it's not working. So if you need more feedback loop for why it's not working, or if you don't understand the color scheme, anything like this, don't hesitate to give some feedback. We are planning to make it more user friendly, and but it's still experimental. So there are a lot of rough edges, especially in the editor.
For sure.
As comes with experimental features, for sure.
If you don't like the colors, you can also change them in the settings. But I think we could improve on the scheme for sure. Yeah.
I feel like that's a conversation that has come up before, but
just a little.
Awesome. All right. Well, thank you all so much for coming on to the show today and walking through everything that you did. It is obvious that there is basically magic at everybody's fingertips right now. It is incredible what you've built and what you have provided for everybody to be able to now play around with and experiment with and even potentially utilize in some of their own projects. So sincerely, thank you so much for coming on today and walking through it with us. This was very informative and very, very cool. Very excited to see where this goes in the future as well.
Well, thanks for having us.
Yeah,
of course. Come back later. If there's anything that you didn't get to show, then that just means you have to come back, right? But also, of course, thank you everyone who watched the show today. It wouldn't be what it is without you and your participation and interaction and questions. So thank you for being here and hanging out with us and enjoying what we do. If you came in late or in the middle or any part of the stream, don't worry, we post all of our streams in video format that can be viewed on demand on both our YouTube and Twitch channel at Unreal Engine. So you can get all the information from here. If you want to go back and rewatch parts of it, you'll be able to do so pretty much immediately after the stream is done. You can also keep up with us on all of our social media at Unreal Engine, as well as, if you aren't already, please come join us on the EDC. Come be part of the community. We have tutorials, we have forums, we have basically anything and everything you could ever need in your development journey there, including ways for you to interact with other members of the community so you can get questions answered, learn some cool things, all that good stuff. So if you're not part of the EDC, please come out there. We're fun. I promise. I promise. Come hang out. It's a good time here. Am I sounding too desperate? No, it's all right. Also, if you're interested in learning more about PCG specifically, or just the Electric Dreams demo in general, there is a series of tutorials and documentation that is now out and released in tandem with the sample project itself. So if you have time, go ahead and dig through those, see what all you can learn and play around with, and most importantly, have fun. Next week, next Thursday, we will be doing even more involving Electric Dreams. We'll be having on members of the audio team to go through some of the updates that were done over on that side of things. So if you're interested in learning more about that, then come back next week and we'll dive into some of those topics as well. But with that, I hope you all have a fantastic rest of your week. One last big thank you to our incredible guests. Thank you so much. This was so much fun. And I'll see all the rest of y'all later. Bye, everyone.
Bye-bye.
Bye.
Yeah.